Have you ever looked up at the sun and felt its warmth on your skin? That's solar energy. We can capture this energy and turn it into electricity using solar panels. Solar panels are becoming increasingly popular as a clean and sustainable energy source. They are popping up everywhere, from rooftops to fields. But how do these shiny panels actually work? Solar panels are made of photovoltaic cells, which are like tiny energy converters. These cells are the heart of the solar panel, capturing sunlight and transforming it into usable electricity. They are meticulously designed to maximize efficiency and durability, ensuring they can withstand various weather conditions and continue to produce energy for many years. These cells are made from silicon, a material found in sand. Silicon is abundant and has unique properties that make it ideal for converting sunlight into electricity. The process of refining silicon from sand involves several steps, including purification and crystallization, to create the high-quality silicon used in solar panels. When sunlight hits a solar panel, it's actually billions of tiny particles of light called photons hitting the silicon. These photons have energy. As they strike the surface of the solar panel, they penetrate the silicon cells, transferring their energy to the electrons within the silicon atoms. When they hit the silicon atoms, they knock loose electrons. This process is known as the photoelectric effect. The freed electrons create an electric current, which is then harnessed and directed to produce electricity. This is the fundamental principle behind how solar panels generate power. Think of it like a game of billiards. Just as the cue ball strikes the other balls, causing them to scatter, photons strike the silicon atoms, causing electrons to be knocked loose. The photons are like the cue ball, and the electrons are the other balls on the table. This analogy helps to visualize the dynamic interaction between light and matter, illustrating the incredible journey of a photon from the sun to becoming a part of our everyday electricity. Now, those loose electrons need somewhere to go. In a solar panel, this journey begins with the interaction of sunlight with silicon cells. When sunlight hits the silicon, it energizes the electrons, causing them to break free from their atoms. This process is known as the photovoltaic effect. That's where the magic of a solar panel's design comes in. Solar panels are meticulously engineered to capture and convert sunlight into usable electricity. Each panel is made up of many solar cells, which are the true powerhouses of this technology. The solar cells are designed with two layers, one with a positive charge and one with a negative charge. These layers are typically made from silicon and are treated to create an electric field at the junction between them. This difference in charge creates an electric field. When the energized electrons are freed by sunlight, this electric field acts like a one-way gate, pushing the electrons towards the conductive metal plates